going over all the functions you're supposed to remember what they look like. We'll add one in that you may not. First up is a square root function. We're going to do everything today using what we call key points. Everything we graph, we memorize 2 or 3 key points. That's how we graph it. That's how we know these things will fit. Key points are really the easy ones to evaluate. Like when you talk about key points, they're the easiest points to figure out. Is that right? This seems fine. They're the easiest points to figure out. This is the square root function, y equals root x. What's the smallest thing you can take the square root of? No, it is not 1. You can't take the square root of x, right? I have no idea what that is. It's not 4. 0. It's the easiest root to figure out. X is 0. The root of x is 0. What's the next smallest number you can take the square root of? 1. 1 is the next smallest number you can take the square root of. And it is 1. And the next smallest number you can take the square root of? Aaron said it. 4. It's not 2, it's not 3, it's 4. What's the square root of 4? There's your 3 key points. You have x values and you have y values. Okay? 0, 0 exists. 1, 1 exists. 4, 2 exists. We call this the arm. Oh, not arc. It's usually called the arm. Does that. By the way, that's, I don't know, a lot of people memorize these things. They really think about it with their arms and their hands and the shapes like that. Might try it. And that is the square root function. I'm not going to bore you with all the nitty gritty like its domain, range, is it even or odd. That's what it looks like. In everything that we do today, we're going to focus on 3 key points, and they're going to be the easiest numbers that we could possibly plug into something. Does yours have all this stuff still on it? Huh? It shouldn't. Did I not? Okay, I see what happened. That's what you see, right? Just that. Good. All right, this is the cube root function. And all cube root functions look like this one. Cube root function is y equals cube root of x. We're going to do 3 key points again. We're only going to use 3, and I'm going to pick them for you. The first thing we're going to take the cube root of is a -1. What is the cubic root of a -1? 1. We're going to take the cubic root of 0. What's the cubic root of 0? 0. Because 0 times 0 times 0 is still 0. You think the last thing I'm going to take the cubic root of is 1. What's the cubic root of 1? 1. Back 1, down 1. 0, 0. 1, 1. You might look at that and think that you actually need to draw a line. So I'm going to extend it just a little bit. You don't ever plot these points, so I'm just going to extend it just a little bit. The next number you can take the cubic root of is 8. What's the cubic root of 8? 2. So you would actually That right there would help you kind of determine what it looks like. Looks like that. Your homework says something. I always forget to do this myself. Your homework says be sure to label 3 points. So yes, label them. Because I want you to memorize them. -1, 1 is a key point. 0, 0 is a key point. 1, 1 is a key point. Taking that 10 seconds of your life out to label that is going to help you memorize, kids. It really is. Now, do you have to plot the last point A2? The only reason I put that up there was so you get an idea of what it actually is shaped like when you draw it, when you connect it to the curvature. That's usually called a snake. A lot of people refer to it as a snake in there. It's a snake. All right, so that was a cube root function. What's up next? Absolute value function. Y equals the absolute value of x. You guys remember what that looks like? What does it look like? It's a v. The cheerleader function. I don't know why I said equals v. We're going to pick 3 things to take the absolute value of it. Anybody got to guess what they are? Give me the smallest negative number you can take the absolute, not the smallest, but -101. Yes. Those are 3 we pick. What's the absolute value of a -1? Absolute value of 0. Absolute value of 1. By the way, tomorrow what we'll do is we'll extend these things and learn how to transform these motor functions to children. So you do need to kind of memorize what they look like. It makes everything way easier. There's another function y equals absolute value of x. Not really doing anything special other than making a little table, am I? Thing is, I just know what points to plug in. And I'm using things that make sense to plug in. Things that are easy to do. They also tend to be centered around the origin, don't they? Kind of go back through it with the exception of the square root function. 0's been in there. Now here's the constant function, f of x equals b. B is a real number. An example of this might be like f of x equals 5. Now that function notation alone functions with some kids. I told the kids to shut pumped up yesterday. Great. That's the little things in life for me. F of x equals 5. Like, what is that really? Because I know notation messes with this. What does it really say? What's f of x fancy for? Y. It's really y equals 5. So f of x equals b is just a particular line that says y is b. What about that line? Is it horizontal? Is it vertical? What's it do? What does it look like? Horizontal. Put that b somewhere else, by the way. That's the constant function. Why is it called a constant function? Because y never changes. Constant for all of its life. We're missing one. How much room you got on that slide? On your paper? Not enough? All right, well, we'll make the identity function really small. Okay. No, you're missing one there. You put it in. I recently put it somewhere. This is f of x equals x. In other words, it's y equals x. You're in pre-calc. That's a line. Where's it cross the xy axis? The origin, the slope. What? You should know that. If you're going to make a table, you're going to use negative 1, 0, 1. You're going to get back negative 1, 0, 1. They're just 3 key points. I don't know that I would use key points on a line, though. There's the identity function, y equals x. It's the identity function because it just returns whatever you give it. So I made that one small on purpose up here. What we're missing is we're missing the cube function. Cube function is y equals x cubed. Anybody remember what that looks like? Nope. In one ear, out the other. She's not along. Three key points, negative 1, 0, 1. And what we'll do is we'll add in a 2. We'll actually use that as a key point. We're going to put it up there because it gives an idea of what it actually looks like. When you cube a negative 1, what do you get? You get negative 1. When you cube 0, you get. When you cube 1, you get. When you cube 2. If you only plot the first initial 3 points, you might think you've got something that looks like a cube root. That's the whole reason I talked about it too late. Too late locks it up like that. Y equals x cubed and y equals cube root of x are inverse functions, so the graphs are a little bit different looking. One likes the x-axis, the other likes the y. They're both things. That's your cube function. We've only done 5 of these things, 6 of them. Wow. What do you think the square function is? Yeah. Y equals x squared. What points do you want to use? Negative 1, 0, 1. What do you have to square negative 1? How about 0? 1. 0, 0. 1, 1. Negative 1, 1. Now, if you look back to your notes, that looks exactly like absolute value did, doesn't it? Absolute value was a B. You've been dealing with quadratics since algebra 1. What kind of shape is a quadratic? It's a U. It's a problem. So you kind of got to know that difference. It is a U. Again, label your 3 key points. Doesn't take long. Of course, I forget to do it a lot. What else is left in here? There are so many mother functions, aren't there? Now, this is the reciprocal function 1 over x. The only, it's one of the few where we actually tend to use more than 3 points. We're actually going to throw, you do these, but I won't. They're not what I require you to remember. Plus, the 0 is kind of interesting too, so it's not even a key point. This is just a small table to help you understand the shape. The reciprocal function is y equals 1 over x. Now, if you plug a -1 in for x here, what's it return for as a y value? -1 for you, but if you were to throw that positive one in, what would it return? Go with 1. What if you threw a 0 in there? Would return 0? Really? If you put a 0 right there, what's that? It is undefined. Can you plot a point 0 undefined? No, there's nothing there. Okay. So 0 is not something that you worry about. You do worry about positive 1. You do worry about -1. All right? And this is one of the few ones where we actually just use 2 key points. It really is. It really is. I guess technically it's 4. We use symmetry for the other one. Take a half, put it right there. F of a half. 1 divided by a half. What is 1 divided by a half? It's 2. Dividing by fractions and multiplication of the reciprocal, it's 2. So if you get a positive 2 when you plug in a positive half, what do you get when you plug in a negative half? -2. Now that's really not enough to justify what the graph looks like to a first-time kid seeing it. So that's why I've got the fifth and -1/5 circle. If you plug in a positive 1/5, what would y be? 5. That's right, Lindsay. If you plug in the -1/5, there should be a negative symbol in there. You get a -5. That'll help you justify what the graph looks like. 1, 1 is a key point. Probably should use one for a number too. But I didn't. 1/2 2. Right there. And then 1/5 5. Really, really close to the y-axis, wouldn't it? I like 1/2 2. I always have. Have kind of the same thing going on the other side. Yeah, I guess I should have given y'all another point here. Sorry, I did not. What happened if I plugged in, like, I don't know, an actual 5? What would I get back? If I plug in a 5 right here, what would I get back? 5. That's getting close to the x-axis, isn't it? So this piece looks like this. This thing has origin symmetry. The bottom looks like that. The only key points that any math book will ever talk about plotting when you draw this thing is 1, 1 and -1, -1. The student is expected to remember the shape of the remainder of the graph. I'll write that down because we had so many points. Key points are 1, 1, and -1, -1. You're expected to remember what the rest of the graph looks like. It's really not that hard. If you just remember the top quadrant, don't you just kind of fold it diagonally over the origin? It's really all you do. You just fold it diagonally over the origin, you've got the remainder of it. And that is a reciprocal function, which we did in Algebra 2. We graphed a couple of these, I think, but I think we mainly used technology to do it. This one will be new to every one of you. Maybe not if you had dual enrollment last year. I think they tend to talk about the integer function. Integer function is kind of funny. It's better known as y equals int x. It's basically what we call a round down function. If you give the integer function, I'm going to tell you how it works basically. Any value between 1 and 2, but not including 2, it returns 1. I know I made mention of the number 2 there. Anything between 1 and 2, but not including 2, means like 1 to 1.9999999, all the way up to 2. It's on your calculator too. Although it's been years since I've looked at it. I want to say it's under math. It is. All it does is it keeps the integer part of a number. It is on your calculator. If you click the math button on your calculator, and you just arrow over to NUM, not num, number, you'll see it there. It's function 5. Int. You give it something like 3.2, it's supposed to return 3. It just throws away the decimals, all it does. Okay? You give it something like 4.99999. What do you think it's going to return? What's it going to return? It's going to return 4. It's not going to return 5. It just rounds the function down to the nearest integer. That's all it does. Now, its graph is kind of interesting. I've got a table off this side, and I know this is going to confuse some kids. I don't mean to do that. I really don't. If x is between -5, including -5, all the way to 4, but not including, it's going to return -5 the entire time. Sorry, -5. It's going to return -5. When x is from -4 to -3, but not including -3, I might have this backwards. These are negatives, aren't they? Those are negatives. Let me work with positives and talk about negatives. Anywhere from 0 to 1, the integer function is going to return 0. Anywhere from 1 to 2, what would the integer function return? 1. Anywhere from 2 to 3, what would the integer function return? 2. Now, let's stick with that, and then we'll just kind of see what's happening. That's how we'll graph the rest of the integer function. But it does get a little bit interesting when you look at the negatives. It's really not that bad. You just all right, the bracket says I can be 0. I can go all the way out to where x is 1. Am I allowed to be 1? No. That's an open hole. When we're doing stuff like that, it's an open hole. I've got that right there. Now, x is anything between 1 and 2. And what's the y value? Always 1. It starts up here, continues out to 2, but I can't actually be 2. Open hole. Moving on, the thing's going to go out to 3. Anytime that x is between 2 and 3, what's the integer function return? 2. So we go up to 2, solid dot, all the way to 3, open hole. It's also commonly called a step function. Because what are you kind of drawing out? Steps. So if you'll remember the first 3, it's easy to work your way down. It really is. Well, those are the kind of ones I would use to think about this one. Now we're going to be stuck between 0 and -1. What's it going to return? If you're stuck between 0 and -1, what's it going to return? One would hope, right? I don't know, let's check it. Give me a number between 0 and -1. Okay, I'll make up a number, -0.1. Didn't do what you expected there, did it? In this case, yeah, it'll round backwards. It's rounding them down. Follow the steps is why I was saying the negative function. That's why when I started this thing off, I was like, wait a second, I need to sort the positives. Follow the steps. That point existed, this point can't. Step goes out. Just take a step down. That's all you do. Take a step down. Next one here from -2 to -1 is going to return a -2. You just take a step down. That is the integer function. So what I do is I memorize the top 3, and I just keep taking steps down. Of course, you have a TI-84 in front of you too, with the integer function. You kind of figure it out. Long set of notes, isn't it? Was it 8:36? I guess we'll pause there. I was really hoping to finish these. Anyways, for your own good, start memorizing these things.